Hi, welcome to Fornet Pi videos. This is DC here. In this video, I'm going to show you how to use the inventory read and the fast inventory read command in ICODE SLI, SLIX and SLIX2 tags. So this inventory read command is present in all the three tags SLI, SLIX and SLIX2. There could be other future tags which probably will also have the inventory read command. So this is a custom command. Now in the custom command, or in general, the custom commands are not defined in the ISO 15693 standard. These custom commands are very specific to the manufacturer. Inventory read command may not be present in a tags that is manufactured by Texas Instruments. For example, it may not be present in tag 8 or other ISO 15693 tags. So this command does two operations. It does the inventory operation. You know, the inventory operation is basically to get the UID of the tag, and it also does the read operations. Now it's very obvious that having inventory read command it's better than sending two commands separately. So doing the inventory and the read together is much quicker than doing this inventory and read as two separate commands. Command and functionality wise, it's identical in SLI, SLIX and SLIX2 tags. However, SLIX2 has more options, and I'll be making a separate video on that. The inventory read command, the response includes some UID bytes. It can be from 0 to 8 bytes of UID. Anywhere between 0 to 8, you might get 1 byte, 2 bytes, 3 byte. Or put in simple words, the response includes a part of the UID. It can also return anywhere from 0 to, it can't be 0 probably, it's just anywhere from 1. It's from 1 to FF or 255 blocks of data. So you have to understand how to use this command. So the option flag is used very much here. When the option flag is 0, the response includes the data blocks. It reads the data. When the option flag is 1, the response includes the data blocks as well as the part of the UID. There is also one more variant of inventory read command that's called a fast inventory read command. Now there is no difference in the command structure or in the format of the response you receive with the fast inventory. The only difference is the data rate from the ICODE tags to reader is twice compared to a normal inventory command. Now I'm going to use two software in this video. I'm going to show you how the inventory read command works using the OmniKey 5022 reader writer, and I'm also going to use the software written for PN5180, and this software I'm going to use to demonstrate the fast inventory read command. However, I somehow could not get the fast inventory read command using OmniKey 5022, and I would advise the users to speak to the technical support of HID Global. So with this background, we are ready for the demonstration. So you can see I've connected my OmniKey 5022 to reader writer. I'm using this ICODE SLI tag, the first generation tag, and this is where you find information in the documentation. This is the document of SLI. You can see the inventory read command. So this is followed by the fast inventory read command if you scroll down. So after this video, I would advise you to read this at least once. The next is the data sheet of SLIX. Here also, as I mentioned before, there's no difference in SLI, SLIX. This is exactly the same text. If you go to SLIX2 tag, you got the inventory read command, and as I mentioned before, this also supports more options in inventory read command. So those options are described in the later part of the document. Say it's called the extended mode and the one that is compatible with SLI, SLIX is called a standard mode. So this video will cover the standard mode. The extended mode I'll be covering in a separate video. So extended mode returns you more information, and it has got, it has got something extra as well. So just have a look at the command structure. This is the custom command, and we know in the custom command you will have the manufacturer code, which is 04 for an XP, and this is the AFI which is used in the inventory. So you can select a certain tags that matches the AFI, and this is the mask length and the mask value. This is where you can target the tags of a specific UID or a UID pattern, and this is where you specify the number of blocks you want to read. You specify the block number, the first block number, followed by how many blocks you want to read. But keep in mind, the number of blocks you mentioned here is always one less than the number of blocks you get in response. Say for example, if I mention the start block number is 0, and if I say the number is 3, you will end up getting the data from 4 blocks. That is, you get from block 0, block 1, block 2, and block 3. So you just have to keep this in mind, and this is how it works. You just have to use it. So, and the response, if you see, this is the response with the option flag set to 0. You get this response. As I mentioned in my slide, when the option flag is set to 0, you will get only the data. So if you requested 4 blocks, you will get the data from 4 blocks. If the option flag is set to 1, you will get both the data as well as the remaining part of the mask bit. Now this remaining part of the mask bit, this makes sense when using the inventory, using a 16 slot inventory, which I'm not covering in this video because certain things cannot be done with some of the readers. So if you keep the 16 slot, the 16 slot inventory is just a way the anti-collision works, and that's that you can. I've made few videos regarding that long ago, or advise you to see that, please. Okay, so just keep in mind, when option flag is 1, you get both the data as well as the rest of the UID, which is not part of the mask and slot number. So I'm using this learning kit for OmniKey 5022, and it's the version 2.8. I'm going to choose the last option. I'm going to connect, or this is also called activate. In fact, when you connect internally, there is an inventory command sent from the reader. So I'm going to see the information like what's the AFI. So first let's try without using AFI or mask length. Now in order to use the inventory read or a fast inventory read command, you must have the inventory flag set. I'm going to set that. I'm going to clear the logs. And also at present the software, as I mentioned before, so you have to have the number of slots set to 1. So you have to have all these 3 flags set. This is obviously, it's always there. We are on high data rate, and inventory set to 1, and number of slots set is also ticked. So we have got inventory command with slot 1, and option flag we are keeping that as 0. So now you are going to see the inventory read when option flag is 0. So without specifying anything, if you just say, remember when option flag is 0, you're supposed to get the data. Now what I have here is I've got the first block set to 0 and number of blocks set to 0 as well, and you'll always get the one more than the number of blocks. So you should, when I send this command, now you will get the data from the first block. Now here the software also shows the grid data on the grid. Now here you see, if you look at the command structure here, these are the command structure. You just have to, now I can quickly tell you once. Now this is the flag, this is the command A0 means inventory read command, this is the manufacturer code, and this is probably the mask length. We are not using the UID mask here, that is set to 0, and this is set to the first block is 0, the number of blocks is also 0, and this last zeros is part of the 5022 command structure. You have to have this last 0, and the response is, these are the 4 bytes of response we got from here to here. Try with different number of blocks. I'm going to say, so I want, say, starting from block 0, I want number of blocks is 6. You'll end up getting 7 blocks. So send. Look at that. So you know the interesting thing about inventory read command is, if you want to read just a few blocks from the tag, you can use the inventory read command. You don't have to read the entire tag. It all depends on the kind of software you're developing. You can see here, first block 0, number of blocks 6. You're getting from block 0 to block 6. You end up getting 7 blocks of data. And you can change. I'm going to have, say, from block number 10. Block number 10, I'm going to read 6 blocks. You'll get from block 10 to block 16. You have to keep in mind, this is SLI tag. If you are using the SLIX2, where the read is password protected, you have to have set the password first before you send this inventory read command. You just have to keep that in mind. You cannot read without setting the read password in SLIX2. Okay, so that is a simple example of using option 0. Next, I'm going to show you how the mask length. So I want to use this mask as part of my inventory. Now, if you look at the UID of this tag, now here the UID is E0 up to here. Now, what I'm going to do is, I'm going to send. You can just copy 44. Sorry, here, so mask ID 44. Okay, so what I'm trying to do is, I'm going to send the last 8 bits of the mask. So I want the tag to compare all the 8 bits from the mask I'm sending. So here, what you're trying to tell the system is, only the tags which has got the last byte in the UID as 44 will respond for the inventory read command. Now this tag matches this 44, so if you send this send command, you will get the same response. What if I change this to 1? Now you're telling any tag with the last 8 bits of the mask, which is 41, must respond. If you say send, now you will get error message. It's obvious because this tag does not match this mask value 41. So keep this 44. You can reduce number of bits. Say, for example, I can say 4, and I can tell, okay, any UID with the last 4 bit having the value of 4 must respond to this command. So just change this number to 2. Send. Look at that. If you look at the command structure here, what's happening is, there are 2 values that are sent. Here this is the 04 and 04. So 04 is the mask length and 04 is the 8 bit of the mask. In the 8 bit, what the software is trying to do is, it's just going to say you cannot send number of bits which is not multiple of 8, even though it just the mask length is 4. So you would think that the value should be sent as 10100. So you cannot send 4 bits. This is padded with the zeros. That's what the software is doing. So to make the value 8-bit size. However, what the tag is trying to do is, it is going to see only the last 4 bits. It compares with this UID. If the UID of if the last bit of the UID or the lower bytes of the UID matches these 4 bits, then the tag will respond for the inventory read command. You can increase this to any length. Say, for example, I'm going to copy all these 3. You just have to be very careful when you use the values here, because this is the lower byte, this is the next lower byte, this is the higher byte. Now I want to send all these, total we have 24 bits, so set this to 24 and clear, and I'm going to change this to say 0 to maybe 20. So if you say send, look at that. So if you look at the command structure, this is 24, which in hex is 18, followed by the 24 bits of the mask value, where this is the lower byte, next lower byte, and the higher byte. Now this tag matches all the three. If you, in case, if I just make a small change here instead of that 6, you should get an error, because obviously this tag does not match with this mask value. So keep in mind, mask value is just a way of looking for a specific UID pattern. So next I'm going to show you how the AFI is used, but this time I'm using the ICODE SLIX tag. So I'm going to activate, this is a different ID altogether, and get this thing, the AFI is 15. So here I'm going to say that I'm using the AFI in my inventory command. So if you try to click send here, the software says inventory flag must be set, then slot 1 flag must be set. You have to do this thing, because without this set, the software doesn't work. In fact, the tag doesn't work if the inventory flag is not set, because this is an inventory command. Inventory flag has to be set to 1. So here I would like to do inventory as well as read from starting block 5. I would like to read 5 or 6 blocks, and I'm not going to use the mask value, but AFI is used. Look at that. If you look at the command structure, sorry, I think there's something wrong. The AFI is not used here, because to use the AFI you must have the AFI set as well. Now this command was run without the AFI. Still it works. It's just a simple inventory read command. Now just clear this thing. Now in order to use AFI, you must set this AFI flag in the request flags. Send. So look at that. So AFI here 15, this is the AFI you are sending. If I change the AFI to 16, a different AFI, that you will get an error message. Okay, so if you're using AFI, the AFI is matched. Now AFI is sent part of the request flag. So when this command is sent to the tag understands that it has to use the AFI. Then it looks for the AFI in the command. Then it compares the AFI in the tag. When all these things match, it's going to return the response for the inventory read command. So I've got one more interesting examples for you. Now I'm using SLIX2 tag, and here it has got a read password set. So if you don't understand the read password, please see my videos on read password for SLIX2. This is a very, very good example. So go into activate, get the information about the AFI is not set here. I'm not bothered at this stage. So if you try to hit the inventory read command, so assume that I want to read from block 1, I want to read say 5 blocks. Say read. Look at that. Oh sorry, I have to set this inventory flag, and I set this slot flag 1. Read. Now the inventory read failed because the tag is not able to read the data. The read is already the read operation is protected by password. So what I'm going to do now is I'm going to set the read password or send the read password. To do that, you have to start from get random number, go to SLIX2 tab, and send the read password. So to do that, I'm going to remove the inventory and use the address, because get the random number, go here, and I know the password of this tag is 1. Set the password. Now we have set the read password. Go back to the inventory read command. Here I'm going to now send this command. No, sorry, you have to set this inventory and the slot and send the read. Look at that. Now we are able to read. So you just saw how to apply the how to send the inventory read command in SLIX2 tag when there's a read password. It's a very interesting example. Okay. Now I'll be using this same tag to show you how to use the inventory read command with option flag set to 1. Whatever you see here works for SLIX and SLI and SLIX. Okay. Now with option flag set to 1, what the datasheet says is it returns both the UID as well as the data. Now let's give it a try. I'm not going to use any UID masking here. I'm going to just send. So look at that. Here, since no mask value is sent, the tag returns with the entire 64-bit of the UID. So this text box here shows the UID received from the response. If you look at the response, the first 8 bytes, or it can be less than 8, as what I'm going to show you now. So the first part of the response is the UID, and the next part of the response is the data block. So this time I would like to match. Say I'm going to match. Say use this is the lower byte. I'm going to copy this thing. Now I'm going to match the last 16 bits. This is exactly what we saw a few minutes ago, using the mask value with option flag set to 0. So I'm going to send an inventory read command with the mask length 16 and the mask value as matching this last 16 bits. Now here we are sending 16 bits of mask value. The remaining 6 bytes or 48 unmatched, and the response will contain the remaining 48, isn't it? Sorry, it's remaining 48 bits will be sent in the response. Say send. So here, look at that. The received UID has got 6 bytes, and these 6 bytes will match the remaining 6 bytes of the UID, because the first 2 bytes has been matched. So we have already told the command that any tag with the matching 70D1 must respond, and because this option flag is set to 1, what the tag does is it will also return you all the remaining part of the UID along with the data. Now the only thing I need to show you is the fast read operation. If you click this fast read, and if you just send, if you hit this send button, you will get an error message. Now this is the error using 5022. So we're still not able to, there's no way in the data sheet or documentation of OmniKey 5022 telling us how to make the reader receive. Probably what's happening here is, if you look at in theory, what's happening here is this is a reader. Okay, the reader is using a standard some standard speeds. Say for example, it's using say 23 kilobits per second speed. That's the default value of the transmission bit as well as the receive bit. This is a received data rate. Okay, now with the fast read command, the tag is returning the data with say for example a different speed. With the higher speed, it could be double this. Okay, it could be say 46 or 56 kbps. If it's 28, you'll have 56. Okay, anyway, so the tag is returning with the double speed. Now this double speed data is not able to be decoded by the reader. Now there must be somewhere some settings in the reader to tell the reader to expect a double speed data from the tag, so which is not possible at this moment of time. So that's the reason why I said the fast inventory command I'm going to show using the PN5180 software. So here I'm using the PN5180 made easy software. You can see I've connected my Arduino along with the board, and I'm going to use a simple tag, ICODE SLI tag, because the fast inventory it also works with SLI. I'm going to activate. Before activate, you have to set the RF1, activate, Now if you go to the R tag, the request flags, I'm going to have the inventory. And before that, what you'll do is, now if I just, if you go here and try to use this fast thing, say send, inventory, I'm going to use slot 1 and go here, say send. We got an error message. Okay, what you have to do in PN580 is you have to tell the board that you are expecting a double speed. Now the way you do that is you can configure the transmission and the reception configuration here in PN580. Now the transmit speed is still the same. The reception speed, I'm going to set it as 53, the double speed, because this is the speed the tag will be using. Load this. So I've loaded this configuration. Now go to this the inventory read command and take this. Just you can bring some more data. So bring 7-8 blocks from block number 3 onwards. Say send. So look at that. We got the response. So if you decode the command structure, you will have, so this is the command A1. See, A0 is for inventory read command, A1 is for fast inventory read command. So you are able to get the response. Now if you are doing the embedded system programming, probably you will notice the data coming from the tag much quicker than using the command without the fast flag set. So that's the only way, that's the only difference you get. Okay, probably we have covered more or less everything about inventory read and fast inventory read command. Thanks for watching.